Welcome to lecture series 8051 microcontroller. In today's session, we will discuss about how to generate the waveform using the timer. So, in this session, what kind of waveform you need? So, the waveform depends on the frequency. So, what is frequency? Frequency is a one complete cycle per second. So, one on and off period we have to take it. Here this is a digital signal, so we are take it as a pulse. Okay, one on and off period we are take it as a pulse. So, based on that we are calculating the frequency. Okay. Once you have to calculate what kind of waveform you need, then what is the frequency of that, then how to initialize this frequency as a counter value. Okay. Suppose you are initializing the value was 10 or 40. So, what it indicates, what is the length of your frequency, that you have to identify. Another thing is, suppose I want to make a delay for 1 millisecond or 3 milliseconds, then that kind of milliseconds how can you assign as a counter value, right? Either the frequency is assigned as a counter value or the delay will be assigned as a counter value. Once you are loading some value in the T0 or T1 registers, then automatically there will be increased or decreased. Okay. So, what value you are loading, based on that only you can generate the waveforms. So, initially we have to calculate, then only we have to load the hexadecimal values. The microcontroller operate only in the hexadecimal values. So, we have to initialize the values in the hexadecimal format, and the count value will be 8 bit or 16 bit. Based on that you have to select either T0 register or TL0 or TH0. Okay. At the same time, whether it is a 8 bit count or 16 bit count, based on that which mode of operation you are selecting. Okay. In case of 16 bit, no other way, you have to select only the mode 1. In case of 8 bit, you can select either mode 0 or mode 2 or mode 3 also possible. In that case, the waveform if you are generating, then it will be repeatedly used, right? Then you can select mode 2. For any kind of waveform generations, you can select the mode 2, that will be better. For simply a single count or whatever you want to adjust the value means, you can load it in the mode 1. Okay. So, in today's sessions we will discuss about how to generate the square wave with either equal length or different length, then how to initialize the counter value, then again how to calculate the delay for particular applications. Take this example, find a period of machine cycle for 11.0592 megahertz crystal frequency. Okay. So, what it represents, they were giving the machine cycle with the frequency value. Okay. One complete machine cycle, this is a one complete machine cycle, that value is 11.05 megahertz, the full width is megahertz. Okay. 11.05 megahertz. Now, the counter or delay, everything is depends on the single pulse only. So, now we have to know what is the frequency for the single pulse. So, how did we calculate a frequency for the single pulse? So, now check it, the machine cycle is divided as number of states. Okay. State 1, state 2, state 3, state 4, state 5 and state 6. So, totally 6 states, each state is divided as 2 pulses, P1 and P2. Okay. So, 2 pulses, totally 6 into 2, 12 pulses are there. Okay. So, one machine cycle which consists of the 12 machine cycle, 12 pulses. The 12 pulses is nothing but one on and off period. This is one off and on. Okay. This is a one pulse period. So, based on that now we are calculating. So, how to get the frequency for the single pulse means that total frequency, the given frequency or the system frequency is divided by 12. So, the frequency, given frequency is 11.0592, which are the machine cycle frequency will be divided by 12 to get the frequency of single pulse. So, the value was 921.6 kilohertz. Okay. Now, we want to know the timing. So, time means automatically 1 by Fp. So, 1 by 92,9021.6 kilohertz. So, which will gives the value of 1.085 microseconds. Okay. So, each pulse value, the frequency is 921.6, the timing value is 1.085 microseconds. So, you keep in mind each pulse timing is 1.085 microseconds. Based on that we can calculate the remaining delays. Now, another example we will discuss. Now, I am asking you to generate the square wave of 50 duty cycle on a bit 0 of port 1. So, what it represents? I have the port 1, right. In the port 1 the signal is port 1.0. So, in this line I want to generate the square wave. The square wave which have the 50-50 means equal on and off. Suppose I am generating more higher value in on period and less period for the off, then it is not a square wave, it is a pulse like a rectangular, right, because on value is higher than the off value. This will be different and this will be different. Here suppose I can write it for 3 millisecond delay, this will be a 2 millisecond delay, but here whatever I have assigned, suppose 1 millisecond means the off period also 1 millisecond. So, equal time period I am assigning, that is why I am give it as a 50%. Okay. So, now in the P 1.0 I want to generate the wave. So, to generate the wave what I have to do or how to write the program. So, first I want to activate the bit position. What it represents? SETB, set bit P 1.0, because here only I want to generate the wave. So, what it will do in the P 1.0 I am setting means the value will be high. Okay. So, the value on the here after making call delay, it will be based on the delay, the width will be get it, right. Then clear bit, okay, P 1.0 means what it represents, the higher value become lower value. Then again I am calling delay, so it will be pass for or the value will be maintained for some time. Then again what I am doing, short jump, here I am jumping, right. So, what it will do, again you are asking to set the value, then calling delay, then clearing the value, then calling delay, then set. So, the same kind you are repeating the process. Okay. So, this is a way we can generate the square waveform by using the set bit and clear bit. Clear bit, set bit, which is used to give the on period and off period. The delay will define how long the width of the off period or width of the on period. The delay how we are initializing means based on the calculation, based on the depends on the frequency or based on your requirement also we can adjust it. Okay. The same program also written in the 2 line. Alternatively, you can written as the same program can be written as CPL P 1.0. So, what it represents? CPL means complement. Suppose if you have value 1, then it becomes 0, if you have value 0, then it becomes 1. So, that way we are complementing. After making complement, you want to make the delay. So, call delay. Okay. So, initially CPL means up and down, right, on and off repeatedly comes. Now, you are giving the delay. So, after on it goes to delay, then off, then goes to delay, then on, then goes to delay. So, based on the delay only you are getting the wave. Then the same process if you want to repeat, then you can write it as the short jump here to here. Okay. Either you can use the first program or this simple line also you can use it for the same waveform generation. Next example is toggle a single LED in port 1.5 using the timer 0 in mode 1. Okay. So, what I am asking? I have a port 1. In the port 1.5 I am connecting one of the LED. Okay. The LED is grounded. This LED should be toggle means on and off. The process should be repeatedly comes. Okay. Then I am using the timer 0. So, timer 0 means only 4 bits I have to use it, right. Here no need, and I am using specified the mode 1 also. For mode 1 you have to assign the value was 0 1. Okay. Now, I am asking you to as a timer. So, you give it as a value of 0, then the gates also to be 0. the timer 1 is not used. So, you can write the value as 0. So, what is the value of this? The value is 0 1. You have to calculate this value based on the number of bit positions, then you have to initialize move t mode comma 0 1 h. Okay. After initializing this 0 1 only, you can get the understanding of timer 0 only. Now, we are using timer 1 is not used. Okay. Then what is your count value, that also you have to initialize here. Okay. Suppose what is your value? FF if we are using means that is the maximum count for the 8 bit. So, FF is a 256 value, that value is calculated, then that will be multiplied with its corresponding time period, we will explain here. Now, take this is a program for executing toggle the LED. Okay. So, we already calculate the t mode value, move t mode the value 0 1. Okay. What it indicates, the timer 0 is initialized in the mode 1. Here we are starting with a 16 bit mode value. Okay. So, my required value was FF2. Okay. So, in that case what I will do it, this is a lower byte data, this is a higher byte data, that is why I use it in the TL register in F2 value and TH value as a FFH value. Okay. So, the mode is initialized, then the counter value is loaded, then what is your target? You have to out the value. So, for that P1.5, suppose you want to on the LED for this much of delay means you can give it as a set bit of P1.5. Okay. But here what is your aim? You want to toggle it. So, simply you can give it as the CPL. CPL what it represents? It will complement the value, right. So, complement the P1.5. So, automatically it will 1 become 0, 0 become 1, then how long you want is based on the delay. Then delay is initialized, then short jump, which is will be repeatedly used for number of times. So, here how they were initialize the delay means, in the delay they were doing some process. What the process means? The timer not is start. Okay. Timer not to start means we have to initialize that bit should be 1. TR not is 1 only, it will start the timer. So, we are giving the comments set bit TR not. So, what it represents? TR not become 1. Okay. Then the same process will be repeatedly occurs till the overflow is occurred. Now, I started the timer value will be increased till reaching the maximum value, the same process is repeated. After reaching the maximum value, then the timer overflow flag will be 1. Okay. Once the timer overflow flag is occur means it exit from the loop, then it will clear the timer 1 as 0, then clear the TF as a 0. Okay. After clearing it will be returned back and the same process will be repeated. So, in the program we have to initialize the timer, then till overflow is occurred the same process is repeated. Once the overflow is occur means we have to clear the, that is stop the timer and also clear the overflow flag. For that we are using the CLR instruction. So, now we will discuss the next program. A switch is connecting to the P1.7. Okay. One of the switch I have connected, this is a switch P1.7. So, here I have connected one of the switch. Write a program to check the status of the switch and perform. If the switch is closed means, okay, I want to display the value either N or Y. Okay. If the switch is closed means on. Okay. When the switch is closed means on, at the time I want only the value Y. If the switch is open means at the time I want the value of N, that is yes or no. Okay. Switch is closed or not, yes or no I want to indicate, that is passed via the P2. So, I am getting some input and passing to the output. The status of the switch I have to pass to the port. So, for that first what I have to do, either set position or reset position, 2 positions I need. Suppose I am setting the position P1.7, it represents the switch is on, the software is the switch is on. Switch on means then what I am doing, the corresponding bit position or corresponding how I am reading the switch means via the carry flag. Okay. First switch on, then via the carry flag I want to check it whether it is 1 or 0. So, for that move C comma 1.7, the corresponding bit is read to the carry. Now, I am checking the carry. If carry is occur means okay, I am moving, because what it indicates, it is 1. If it is 1 means I want to move it as a yes. Otherwise, no carry means it will follow the next instruction, which is P2 comma no n, right. The same process will be repeated till whatever you want. Okay. So, we are set the position and moving to the carry flag based on the carry. If the carry is set means it indicates yes, the switch is closed. If no carry means the switch is not closed. So, either n and y is moved to the P2. Okay. So, this is one kind of example how can we read the data from the switch. Now, we will discuss how to find the value to load the timer. Okay. We are initializing some values in the T0 or T1 register, it will be either 8 bit or 16 bit. How we are initializing? Okay. So, based on our requirement only we are initializing. So, we will discuss how to initialize. Suppose you are taking the system frequency as crystal frequency, which is 11.0592 megahertz. Okay. So, the given frequency is divided by 12, then it will be divided by 12, then by taking the inverse I will take it as the time delay. So, the time delay is calculated as 1.805 microseconds. Okay. 1.85 microseconds, this is for the one pulse. So, for the time delay for a single pulse, which will be 1.805 microseconds. After that, that value will be subtracted from the, if it is a 16 bit register, I have to calculate from the 2 power 16. If it is 8 bit, then 2 power 8, which is 256, either 256 or 65536 minus the given number. That will be given in the decimal value. That decimal should be converted into the hexadecimal. That hexadecimal only we are loaded in the register. Okay. If it is a 16 bit means, then it will be lower register, higher register. The lower value is XX, which is loaded in TL register. The higher value YY is loaded in the TH register. So, this way only we are initializing the counter value in the counter. So, according to our discussion, now I am asking you to calculate the counter value for 10 millisecond. Okay. So, 10 milliseconds what you will do? For 10 milliseconds I am asking. Okay. So, you know the value of 10 milliseconds. So, directly you can calculate the delay, which is equal to 10 millisecond divided by 1.085 millisecond. So, after dividing I get the value as 9216. Okay. If any fraction is occurred, you have to take it only in the integer part. So, now how to initialize the value means, according to this value I will take it as a 16 bit counter 2 power 16, which is 65536 minus the given value 9216. So, after subtracting this I get the value as 56320, right. This is a value which is a decimal value. So, we cannot initialize in the T0 register. So, it should be converted into the hexadecimal, then only we can load it. So, after converting the hexadecimal, the value was DC00. Okay. You divide by 16 and calculate it. 56320 divided by 16, you calculate, you will get the DC00 H value. Okay. So, after that it should be splitted as TL0 and TL1, sorry, TH0, lower register, higher register. So, this is a counter value. How we have to initialize means, move TL0 comma 00H, right, then move TH0 comma DCH. Okay. So, this is a way we are calculating the hexadecimal value for the given delay, then we have to use some instructions to initialize in the T0 register. We will take another one. Now, the following program generates a square wave on P1.5 continuously using the timer 1 for a time delay. Find the frequency of the square wave if crystal frequency is 11.0592 megahertz. In your calculation, do you include the overhead due to the instructions in the loop? Okay. If any overhead is occur, you can initialize it. So, according to that, here timer 1 is given, right. Then based on the value, we have to select either mode 0 or mode 1. So, here I have initialized with the mode 1 with timer 1. So, what is the value? Mode 1 means 0 1, timer 1 with a counter. So, 0 timer usage, right. So, I put it as 0, the gate also 0. At the time the timer 0 is not used. So, the value was 10 H, the hexadecimal value. So, that value is initialized here. Okay. Then we initialized some counter value which is 7634 H. Okay. After initializing, I am starting the timer to start. So, once the timer is start, then automatically the value is loaded in the T1 register, then I will connect it with the timer flow flag. So, this value will be started to count by using the TR1 is equal to 1. So, after counting, this counting when it will be stopped means after set by the timer overflow. So, till that I am repeating the process. When the timer flow flag is set means what it indicates, if the overflow is occur, then we stop the process and stop the process by clearing the TR1 by using CLR instruction. Then I will complement the bit position, then clearing the timer overflow flag, then again I am repeating the process. The same process will be repeatedly comes. Now, I want to know what is the delay value for the given value, which is 7634. So, for that the 7634 is a hexadecimal value. In the 2 power 6 value, maximum value is 4f. So, the 4f minus the given hexa value, what you get? 89 CB. This plus 1, because we always started with 0, so plus 1. Okay. So, this value become 89 CCH. Okay. So, now this value will be converted into the decimal, then the decimal value will be multiplied with 1.805. So, this is a required delay. Okay. So, the given delay subtracted from this value, then plus 1, because we are started with 0 to f. Okay. That is why the 0 value is added here. Then that value is multiplied with, because we are divided by 1.085, that should be multiplied to compensate. So, we get this delay. This delay is get it for only on period. Suppose you want to get it for off period also, then we have to multiply it by 2, then only you will get the complete pulse width. Okay. One on period and off period. So, that is why we are multiplying with 2, you get 76.54. Then the corresponding frequency, either if you want to calculate the delay of this, it is n of 76.548 millisecond. Suppose if you want to calculate the frequency of that, then you can take the inverse of that. 1 by time is the frequency, which is 13.06 hertz. This is the way we are generating the delay of square wave. The another one, suppose I ask you to generate the pulse with the 5 milliseconds. 5 milliseconds means what you will do? The 5 milliseconds will be divided by 1.085, because the frequency is 11.052. Already we know this value is divided by 12, then by taking 1 by fp you get this value 1.085, that is divided by 5 milliseconds divided by 1.085, you get 4608 clock pulse. That will be calculated, subtracted from 2 power 16, then you get decimal value, that should be calculated in the hexadecimal, then we have to load it. Then which timer you want, you can select it. Here you want the timer 0, so here you start and write the program. Okay. Likewise, you can generate any kind of waves. I will give one assignment, you try at your time. Assume crystal frequency 11.059 megahertz. Write a program to generate a square wave of 50 kilohertz frequency on the pin P2.3 in mode you can automatically select it, right, in timer 0. Okay. So, in today's session we have discussed how to generate the waveform, how to define the width of on period and off period, alright. So, based on the frequency they were giving for 1 machine cycles, that should be divided by 12 to calculate for the single pulse. Then single pulse, whether it will be the on period or off period, again divide by 2, then we are using the frequency. The frequency value will be calculated to define the delay value. The delay is loaded in either in T0 or T1 register. Then what type of values you have, either 8 bit or 16 bit, based on that you can select any one of the mode. Okay. So, this way you can initialize it. First you have to calculate the pulse will be subtracted from the total number of possibilities. In case of mode 0 means 2 power 13, in case of mode 1 2 power 16, in case of mode 2 2 power 8. So, that possibility is subtracted, you get number of pulses that should be converted into hexadecimal, then load it into the any one of the register, either T0 or T1. So, I hope you enjoyed and understand how to get the or how to generate the waveform.